Hello YouTube, quick video on the weekend to test theory that zinc chloride makes for better charge retention on supercapacitor / hybrid devices when they're not being charged. So I've made a really rough and dirty device with a bit of aluminium out of the kitchen drawer, shiny side contact in the carbon, because I read somewhere that the dull side actually has a coating on it, and using a bit of fish filter carbon, active carbon, buzzed through my wife's Thermomix when she's out and about with the kids, don't tell her, strained it through a fancy tea strainer, and the rest is history. Put down some kitchen paper matting, and electrolyte wise I've got some 1 molar zinc sulfate and around 1/10 of that concentration zinc chloride, and again check the warnings if you do buy zinc chloride. Charging it up with this thing called a B3603 fed from a 3S LiPo battery, which is about 12 volts, but normally it's putting in 0.41 of a volt, and at the moment it's putting in 0 milliamps. The displays alternate flashing there, which roughly agrees here with my very cheap multimeter put across the device, although it does say replace battery over here. Anyway, we're pretty close between the two. What was interesting about this device when I ran a few cycles this morning was when I removed the charge cable, it stayed extremely stiff, and in fact it barely altered a couple of millivolts. So that was really encouraging to me, and this is only my first experiment off a pretty bad sort of a device, so I'm taking it not so seriously, but I think I definitely, to quote Homer Simpson, not licking toads, it's definitely a double negative test that it's not a bad thing necessarily to add zinc chloride to your electrolyte, if that all makes sense. Got a little resistive load here that you can dial in, so I've set that to 100 ohms, which at 0.4 of a volt using Ohm's law says that I'll be drawing milliamps nominally through here, but if I quickly recharge that and then put up the resistive load, it very quickly sags down to less than half. Now, at first I thought this device wasn't perhaps a very good device, but if I check really rough and dirty, and I'd never do this with a big supercapacitor, the internal resistance comes back extremely high. The effective internal resistance, that's not really a very accurate thing to do, but the point is that I suspect this device isn't particularly good at sort of letting charge out. However, what was interesting also this morning is if I remove this resistive 100 ohm load, it very quickly starts to bounce back almost exactly to 0.41 of a volt, which is telling me that potentially this is a reasonably stiff sort of a device, just really high internal resistance, so it sags like you know what, but give it enough time and it'll pretty much fully recover. So potentially there's a fair bit of energy in here, it's just really bad at delivering it. But that wasn't really part of my experiment, really, is to get some sort of an indication that zinc chloride may help with charge retention of a device. And I'm thinking here of things like solar banks would need, you know, a good sort of overnight ability to store charge. So zinc chloride so far looking good. Hopefully all this is useful to some people. I've also started a fairly basic DIY supercapacitor group on Facebook. There's not much volume going through there at the moment, but if you want to join and contribute, that would be absolutely fantastic. If you've got any ideas, we'd love to hear from you. And if you could smash the like button or share this video or subscribe, that would certainly help me as well. Thanks everybody.